Okay, so this is going to be the solution to question 13 on the 116 exam from Winter 21. And this was moving into section 16.3, looking at standing waves on a string and looking at technically the fundamental wavelength. So the sort of the modes of sort of the allowed resonant frequencies is given by some integer value times the fundamental frequency f1, where the fundamental frequency is v divided by 2l. Now the question didn't get in as quantitative as that. We're really just looking at counting determining the mode number, then determining the fundamental frequency, and then seeing which was the next highest frequency in this sort of sequence. That was sort of what, so it was a little bit, wasn't again as quantitative as these questions can be, but more looking at recognizing how do I determine the value of m. Do I count the nodes or antinodes? In this case I should be definitely counting the antinodes, and then thinking about that the f of m will be equal to an integer multiple of the fundamental. So they were the key concepts for this question. So for question 13, so we have power of lecture demonstration. A physics instructor creates a standing wave in a string fixed at both ends. So that's where, that's the context. Standing waves on strings. An image of the standing wave is shown below for when the string is oscillating 120 hertz. So when you're counting the mode number for a standing wave in a string, you want to be counting the number of antinodes. So that's 1, 2, 3, 4. So in this particular case, this is referring to m equals 4. So if we wanted to find the fundamental, we can know that f of 4 is equal to 4 times f of 1. In this case, it's oscillating 120 hertz. That's what f of 4 is equivalent to. So f1 is equal to 120 hertz divided by 4, which is 30 hertz. I think in the other case I had maybe three antinodes and it was 60 hertz, so the fundamental would have been 20. So then, but the same type of method again, count the number of antinodes and divide to figure out the mode number, divide the frequency which was given for that particular mode by the number of antinodes to give you the fundamental, and then you're basically adding 1 to find the next highest frequency. So the next highest frequency after 4 is going to be 5. So f of 5 is going to be 5 times f1, which is 5 times 30 hertz, which is 150 hertz. So that would, for this particular question, that was the next, and I think the other one was, I think it was 60 hertz, and then the next one with a fundamental of 20. The next one I think was 80 hertz, but the same, of course, same method, technique applies. Okay, yeah, I think that was the main part of this question. Again, was to distractors would have been incorrectly counting the number of nodes. That's not correct. That's not how we count the mode number for standing waves in a string. So they would have been sort of the distractors. So we're sort of looking at divided by 4 rather than by 5. So 120 divided by 4 gives us 30. 30 times 5 gives us the 150. Okay, yeah, I'll wrap that question up there and follow up with question 14.